Well, hi everyone. All right, just going to work through the quiz 13 just for your references, just for reference so you can study when you see this on the final. All right, so we have the function f of x equals 3x squared minus 5x minus 2 over x squared minus 4. And then we've got some questions here. Are there any holes in the graph? If yes, list their coordinates. All right, well, to find holes, we've got to get this thing factored. I'm going to go with the numerator, the old-fashioned way that we learned earlier. 3 times negative 2. So I need something that multiplies, two numbers that multiply to negative 6 and add to the middle term, middle coefficient there, negative 5. Let's see. So if I do 2 times 3, negative 2, negative 3, that's actually positive 6. So I think I need to go 6 and 1 here and make this negative. And then negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. So that's what I'll do. But remember, that is so that I can split up the negative 5x into negative 6x plus 1x and then minus 2. And then, so I could factor by grouping. And 3x is the GCF of those two terms, and that is x minus 2. And then I think 1 is the GCF there, and that is x minus 2. So we're looking at 3x plus 1 times x minus 2 when we factor the numerator. I'm going to write that down. 3x plus 1 times x minus 2. On the bottom, I've got a difference of squares. That's x plus 2 times x minus 2. All right, so yes, there are holes. Because we're canceling out these x minus 2, this GCF, this common factor in the top and the bottom, we're canceling it out. Because of that, we're going to have a hole when x is 2. Okay, so my simplified function is f of x equals 3x plus 1 over x plus 2, but we do have to consider that x can't be 2 in this original part. So our function is this function with that hole right here because of the common factors in the numerator and denominator. So that's 2, and then the y-coordinate is 3 times 2 plus 1 over 2 plus 2, which is 7 over 4. So there is a hole in the graph at 2, 7 over 4. Otherwise, this graph looks exactly like this graph. All right, what are the zeros of f of x? And I'm going to use the simplified version from here on out. 3x plus 1 over x plus 2. To find the zeros, x can't be negative 2. Whoops. Okay, zeros, not asymptotes. So the 0, that's when the numerator is equal to 0. So 3x plus 1, when is that 0? I subtract 1 and then divide by 3. X equals negative 1/3. That makes the numerator 0, which makes the whole function 0. Now, what is or are the vertical asymptotes? That's when the denominator, what value of x will make that 0, would make this function undefined. So x equals negative 2. That's a vertical asymptote. Horizontal asymptote, this is the degree of the numerator is equal to the degree of the denominator. All right, now when that is the case, we take the lead coefficients, and I could do it here and here or here and here, but it's 3 over 1 So y equals 3 is a horizontal asymptote. So when I go to make this graph, I'll just start here. I'll start with this horizontal asymptote at y equals 3. Okay, I'm going to put x equals -2 as the vertical asymptote that we have. I've got a 0 at x equals -1/3. So right around there is a 0. I've got a hole at 2 and 7/4, which is 1 3/4. So I got a hole right around here. Okay, so this is looking like our curve is going to go like this down here. So that's what I'm going to kind of try to draw that. And then I meet here, and then I continue and draw this. So I think we got that curve there. And then the other one's probably right up here somewhere. So I want to get a couple of values, though, using f of x equals, let's see. I'm thinking real quick. F of x equals 3x plus 1 over x plus 2. I didn't do a y-intercept. They didn't ask it in the question. But if I find f of 0, I've got the y-intercept. So 3 times 0 plus 1 over 0 plus 2. That is 0. That's 1. And that's half. So I'm real close there in my drawing. So that curve's going pretty well, I think. I want to find just a few more. I'm going to look at what f of -3 is in here. And that's 3 times -3 plus 1 over -3 plus 2. -9 plus 1 is -8. -3 plus 2, that's -1. So that's 8. So I'm going to plot -3, 8 right here. That is a point on the graph. Let's find what f of -5 is. And just come over here a little bit and see how high up this will go for that curve. And then I'll just try to make the curve from there. 3 times -5 plus 1 over -5 plus 2. It's -15, and 1 is -14 over -3. That's positive. 3 times 4 and 2/3. -5, 4 and 2/3. 4, 2/3, right around there. All right, so I think we're getting a bend here. So I'm going to kind of come up from up here, bend it through there, and come down toward that asymptote. All right, that's that one. Now let's look at this one. Use the function f of x equals 2x squared minus 7x minus 3 to provide information for the below. All right. I'm going to factor the numerator. Anything multiplies to -6 and adds to -7. 6 times 1, but they've got to be different. So I don't think we're going to be able to factor the numerator. I'm not finding anything to fit here. So no holes in the graph. There's no common factor in the numerator and denominator. All right, are there zeros? Well, let's look at 2x squared minus 7x minus 3 equals 0. We couldn't factor it, so I'm going to use x equals -b plus or minus square root of b squared minus 4ac, all of that over 2a. Okay, and that is 7 plus or minus That's 49 there. It's positive 49. 24. 49 plus 24 is 75. 73, I mean. 73, and that's over 4. So zeros. 7. Wait, clear that. I'll put that in parentheses. 7 plus square root of 73 Alright, I didn't mean to have that one. Let me delete that one. Divided by 4. Okay, so x is approximately 3.9. I'm going to change that plus to a minus. And negative 0.4. X is approximately negative 0.4. Okay, so there's my zeros. That might come in handy. Are there vertical asymptotes? X equals 3 is going to be a vertical asymptote. Slant asymptote. This is a case where n is greater than m. So I'm going to figure out the equation for the slant asymptote. And n is equal to m plus 1. That's the other case here. Just up a little bit more room right on top of there. We have to use long division. So I'm going to take 2x squared over x, and that's 2x. And I'll put the 2x right there. And then I'm going to multiply. 2x times x is 2x squared. Negative 3 times 2x is negative 6x. Then I'm going to subtract. Negative 7 plus 6 is negative 1x. And I'm going to bring down the minus 3. And, okay, I was going to say, ooh, wait a second. This does factor, but it doesn't, because that's a negative 1x. So I need a minus 1 here. And that gives me negative 1x. Negative 1 times negative 3 is positive 3. And then when I go to subtract that, I got negative 3 minus 3. That's negative 6. So minus 6 over x minus 3. There's the complete division. This is the only part. This becomes negligible as x gets very big or as x gets very small. So y equals 2x minus 1 is my slant asymptote equation. All right, let's draw it. Y equals 2x minus 1. So I'm going to put negative 1 here. I'm going to go up 2 over 1. I'm drawing the slant asymptote first. Okay, there's my slant asymptote. My vertical asymptote, x equals 3. All right, my 0, I got 3.9 right there. I've got negative 0.4 right around there. I'm going to look for a y-intercept. I'm going to put f of 0 in. 2 times 0 squared minus 7 times 0 minus 3 over 0 minus 3. That's 0. That's negative 3 over negative 3, which is 1. Okay. All right. Now, okay. All right, so I got the y-intercept down there, and I've got this here, and I know we'll be close there. We probably go like this. Might be interesting to see something. Wonder what f of 5 is, just to get another viewpoint here. F of 5, I got 2 times 5 squared minus 7 times 5 minus 3 over 5 minus 3. 25, 50. 50 minus 35 is 15. 15 minus 3 is negative 18 over 2. That's negative 9. So 5, negative 9. Whoop. Wait. 50 minus, oh, miscalculated. All right, let me try that again. 2 times 50 minus 35 is 15. 15 minus 3 is 12. 12 divided by 2 is 6. So I'm going to put 5, 6, like right here. All right. I just have a feeling that it's closer here, and it gets a little further away, comes here, and then comes back up toward here. And I've got these 2 points. Let me find what f of 2 is. See how high up that would be. F of 2, so 2 times 2 squared minus 7 times 2 minus 3 over 2 minus 3. It's negative 1 on the bottom. 2 squared is 4 times 2 is 8. 8 minus 14 is negative 6. Negative 6 minus 3 is negative 9. So negative 9 over 2, that's positive 9. So 2, 9, it's like right here. So we're close, and we curve right around there at that nook, and oops, and then we get closer to the asymptote. And we get closer up here too. All right, that's what we got here, guys.